Today, we are diving into one of the most profound questions humanity has ever pondered: the origin of life and the universe itself. How did life emerge from seemingly lifeless matter? And what sparked the universe into existence? While many theories have been proposed, from spontaneous natural processes to intelligent design, we will explore these ideas through a lens that combines scientific inquiry with philosophical depth. Before we delve into the details, we will explore the concept of dynamic order within life and the cosmos. This will help us understand their origin. Life and the universe both embody dynamism through the perpetual motion of their components. In the universe, celestial bodies like stars, planets, and galaxies are constantly in motion, interacting through gravity, magnetic fields, and other forces, creating a structured yet dynamic cosmos. Similarly, in life, continuous movement is evident at molecular and cellular levels. During gene expression, enzymes actively transcribe and translate genetic information, while molecular machines like ribosomes synthesize proteins in a highly organized process. These intricate, ceaseless motions highlight a dynamic order within both the cosmos and living organisms, where complex activities are sustained by unceasing motion and precise interactions. How did these systems with dynamic order begin?
Theoretically, there are only two ways to assemble any multi-component dynamic system: gradually or instantaneously.
Gradual origins describe dynamic systems that evolve step by step, like life on Earth adapting over millions of years or stars forming from collapsing gas clouds. In this process, complexity builds gradually, with each change adding to resilience and adaptability over time. On the other hand, instantaneous origins suggest dynamic systems that emerge fully formed in a single moment. Many systems are composed of parts that are functionally interdependent, meaning that if one part is missing, the entire system fails. This concept is commonly discussed in terms of irreducible complexity. For example, in a complex biochemical pathway, several enzymes might need to work together precisely. Removing one renders the pathway non-functional. But if individual parts are useless without others, how can a step-by-step process produce functional intermediates? Here, non-functional intermediates will inevitably be produced, frustrating the gradual assembly process. Non-functional intermediate steps may have no evolutionary advantage and thus would be unlikely to persist. In such cases, to avoid the production of non-functional intermediates, the simultaneous origin of multiple components is necessary. Gradual assembly is indeed problematic for systems where the components are interdependent and work together to perform specific functions. As systems grow more complex, they often require coordinated mechanisms to maintain functionality. For instance, a metabolic pathway needs not only enzymes but also regulatory molecules to control the rate and efficiency of reactions. The stepwise addition of these components could be highly inefficient, and the risk of system instability increases at each stage, especially if critical thresholds of coordination are not met. Gradualism struggles with this complexity threshold, as minor changes can destabilize the entire system. In contrast, an instantaneous formation of a complete system bypasses these gradual integration issues. In such a model, all parts would be present from the beginning, fully formed and compatible. This avoids the need for intermediate, partially functional steps. Moreover, an instantaneously created system could be fully optimized for function from the outset, without the trial and error modifications of gradualist processes. Each part would be positioned to immediately interact dynamically with other components in a coherent, fully operational manner.
Spontaneous natural processes are not guided by an external intelligent agent and rely on random mutations and natural selection to build complex systems. Since random mutations are uncertain, such natural processes must pass through a series of waiting periods to build a multi-component system. This makes all natural processes inherently gradual, leaving very little chance for the simultaneous and instantaneous origin of interdependent parts. To generate interdependent parts simultaneously and instantaneously, multiple coordinated mutations would need to occur in single step. The probability of this happening spontaneously, without the guidance of an intelligent creator, is astronomically low. Therefore, for the instantaneous assembly of a multi-component system with interdependent parts, the guidance of an external intelligent creator is essential. But how exactly does an intelligent creator create a multi-component dynamic system instantaneously? We will explore this question using the analogy of a watch. William Paley famously used this analogy to argue for the existence of an intelligent creator.
The manufacturing of a functioning watch goes through 3 specific phases, a process that reflects the typical transitions required to create any dynamic system. Formation of such systems generally requires a sequential development from individual components, to a static arrangement, and finally to an active, fully operational dynamic state.
We will discuss these specific phase transitions now. 1. Materialization phase. In this first phase, individual components of the watch, such as gears, springs, and hands, are meticulously crafted based on a blueprint. Each part is designed with specific dimensions and functions in mind, ensuring that it will fit precisely with the other components during assembly. This is the phase where the elements necessary for the watch's function are brought into existence, laying the groundwork for the structure. 2. Static organization phase. In this phase, the crafted components are gradually assembled into a complete, static structure according to the blueprint. Each part is positioned in relation to the others, forming a coherent arrangement, but the system remains inactive without an energy source. Although fully assembled, the watch has no functionality at this stage. Each part is aligned and ready, but it remains a static, inert organization. 3. Dynamic transformation phase. This final phase occurs instantaneously when the watch is wound or powered, transforming the static structure into a dynamic, functioning system. Energy flows from the mainspring, driving the gears and escapement to regulate time. This activation turns the watch from a static organization into a fully operational dynamic system, as each component now works in synchronized motion to fulfill the purpose of timekeeping.
So, although we can't create a multi-component dynamic system instantaneously in a single step, we can create such systems by first assembling their parts into a static organization, which then transitions to a dynamic phase instantaneously. Dynamic systems like life or the universe could have been created in a similar way, avoiding the need for parts to be gradually assembled while the system is already running.
Formation of a static organization offers several important advantages, especially when constructing complex systems. 1. Application of blueprint. In the static phase, it's much easier to apply a detailed blueprint to the system. Since the system is not yet in motion, each component can be placed precisely as planned, and the roles of individual parts can be predetermined with clarity. This static phase also allows information to be incorporated effectively before any dynamic activity begins, ensuring that all elements align with the intended design. 2. Fine-tuning. The static phase allows for careful adjustment and calibration of each part before the system is activated. Specific measurements can be applied to components, and they can be positioned in exact order and alignment. Fine-tuning these elements in a static arrangement is far easier than attempting to make adjustments while the system is in motion, which could disrupt functionality or require stopping the system altogether. This fine-tuning ensures that each part is in optimal condition and correctly aligned before the system is dynamic. 3. Simultaneous integration of interdependent parts. In a static organization, interdependent parts can be assembled simultaneously, which is crucial for creating irreducibly complex systems where all parts must be present for functionality. This avoids the issue of non-functional intermediates, which would lack purpose and stability in a dynamic, gradual process. By assembling all required parts in a static setup, the system is able to transition smoothly to functionality, with every interdependent component in place and ready to operate cohesively. These advantages demonstrate how a static phase provides a controlled environment that supports precise assembly, alignment, and integration, allowing for the construction of highly complex dynamic systems without the disruptions or inefficiencies of incremental, in-motion assembly.
The emergence of dynamic systems, such as life and the universe, can be understood through specific phase transitions involving fine-tuning, hierarchical organization, and sudden shifts from static to dynamic states. Now, first we will discuss phase transitions necessary for origin of life, and then we will discuss phase transitions necessary for origin of the universe. Origin of life went through following phases. 1. Creation of building blocks of life. 2. Creation of static non-aqueous organization. 3. Activation of protective mechanisms. 4. Sudden transition to dynamic aqueous living systems. The initial phase involved the synthesis of essential biomolecular components like amino acids, nucleotides, lipids and sugars. These components were formed under precise conditions, ensuring their stability and proper configuration.
Following their creation, These biomolecules were assembled into a fine-tuned, non-aqueous static organization. In this phase, molecules were protected from the potentially damaging effects of water, allowing for the formation of complex structures such as proteins and nucleic acids. Additionally, a large-scale hierarchical organization was established, with biomolecules arranged into intricate, ready-to-activate systems.
To prepare for the next phase, protective mechanisms were activated within the static organization. These include structures like membranes or encapsulating barriers that could safeguard sensitive components from hydrolysis when the system transitioned to a dynamic aqueous state. The shift from static to dynamic life was achieved instantaneously through the sudden inclusion of the breath of life. This abrupt input triggered metabolic activity, self-replication, and other life-sustaining processes, transforming the system into a living, self-sustaining organism. Origin of the universe went through following phase transitions. 1. Creation of matter from nothing with quantum to classical transition. 2. Creation of a static fine-tuned organization. 3. Phase of dynamic expansion. 4. Phase of guided evolution.
The universe began with the creation of matter from nothing, transitioning from quantum fluctuations to classical particles. This phase involved the emergence of fundamental particles like electrons, protons, and neutrons, all fine-tuned to specific properties required for stable matter formation. The shift from a quantum to a classical framework laid the groundwork for the structured universe.
Next, the universe was organized into a highly ordered, static arrangement. This stage saw the formation of large-scale, hierarchical structures, such as dense matter regions that would later form stars, galaxies, and other cosmic entities. The static organization was initially smoky, due to extremely high temperatures, where matter existed in a diffuse, hot state. The universe was in a finely tuned, stable state, with matter, forces, and particles meticulously arranged to support future dynamics. These static configurations served as the foundation for the subsequent dynamic processes. The transition from a static state to a dynamic universe was triggered by a sudden input of energy, which initiated the rapid expansion of space. This energetic burst set the organized matter into motion, leading to the formation of stars, galaxies, and cosmic structures, transforming the universe into a dynamic system defined by motion, time, and celestial interactions. In this phase, various aspects of the cosmos were systematically fine-tuned. This process resulted in a fully developed, life-supporting universe.
1. Irreducible complexity. The concept of irreducible complexity suggests the simultaneous origin of multiple interdependent components. It is reasonable to consider that the simultaneous application of these interdependent parts would be more feasible in a static phase rather than a dynamic one. Causally circular biological systems highlight this simultaneity, implying that a static organization was necessary to bring these components together before initiating dynamic functionality. 2. Fine-tuning in physical systems. Fine-tuning is more easily achieved within a static system. The precise arrangement of forces and particles required for a stable universe is more manageable in a static state, where conditions can be meticulously controlled before transitioning to dynamic processes. 3. Fossil record evidence. The fossil record shows the sudden appearance of fully formed, complex life forms, without gradual intermediate stages. This pattern supports the idea of an instantaneous phase transition from a static organization to a dynamic living system, rather than a gradual evolutionary process. 4. Solid phase synthesis in the origin of life. Evidence suggests that the origin of life involved a solid phase synthesis and assembly of biomolecules before the emergence of a dynamic aqueous system. This phase transition was necessary to resolve the water paradox in the origin of life, as the solid phase with minimal free water allowed protective mechanisms to be activated, preventing biomolecular degradation. 5. Dynamism in life and the universe. The transition from static to dynamic states in both life and the universe can be compared to the transformation of a watch. Just as a static watch requires a sudden input of energy from a battery to set its components in motion, life in the universe did require specific triggers to shift from static organization to dynamic activity. In biological systems, the sudden inclusion of the breath of life transformed static biomolecular assemblies into living, self-sustaining organisms. Similarly, the universe transitioned from a finely tuned, static state to a dynamic, expanding cosmos through a sudden input of energy. These phase transitions were necessary to activate the complex, dynamic behaviors that define both life and the cosmos.
6. Early emergence of complex galaxies. The early emergence of complex galaxies suggests that they were assembled during a static phase, followed by an instantaneous transition to a dynamic universe. Gradual evolution is problematic for the early origin of complex galaxies, as there would not be enough time for their formation. Moreover, the in-motion and gradual assembly of parts within a complex galaxy presents additional challenges.
These points collectively illustrate that phase transitions from static to dynamic states were crucial in both biological and cosmological contexts, allowing for the emergence of complex, functioning systems analogous to a finely crafted watch set in motion.
The Quran presents a model of creation involving distinct phase transitions, where both life and the universe shift from a static organization to dynamic systems through divine command. Indeed, the example of Jesus to the God is like that of Adam. He created him from dust. Then he said to him, "Be," and he was. Quran 3:59. This verse suggests that life was initially created in a static form from basic elements and then transitioned instantaneously into a dynamic living system through the divine command. Be. This indicates a sudden activation of life, bypassing gradual development and emphasizing an initial phase of complex static organization. Have those who disbelieved not considered that the heavens and the earth were a joined entity, and we separated them and made from water every living thing? Then will they not believe? Quran 21:30. This verse indicates that initially, the heavens and the earth were a unified, static entity. Complexification or organization was achieved during this static phase. The phrase, "we separated them," signifies a sudden transition from this highly ordered static state to a dynamic, expanding universe. This concept differs from the Big Bang hypothesis, where complexification occurred after the dynamic phase arose. In contrast, here, complexification occurred in the static phase before transitioning to a dynamic state. The verse also mentions the aqueous phase in the origin of life. The Quranic verse that refers to the dynamic expansion of the universe is, "And the heaven we constructed with strength, and indeed, we are its expander." Quran 51:47. This verse indicates that the heavens were not only created with strength but are also continuously expanding, aligning with the concept of an expanding universe.
We are mentioning two verses here that indicate a phase of cosmic evolution. First verse, "Then he directed himself to the heaven while it was smoke and said to it and to the earth, Come into being, willingly or by compulsion. They said, We have come willingly." Quran 41:11. Second verse, "And he completed them as 7 heavens within 2 days and inspired in each heaven its command. And we adorned the nearest heaven with lamps and as protection." Quran 41:12. These verses describe a guided transformation where the initial, smoky, state of the heavens was shaped into a structured cosmos, emphasizing that the universe's development was purposeful and meticulously arranged. This indicates a form of guided evolution. As we have already discussed, this evolution differs from the cosmic evolution described in the Big Bang hypothesis. According to the Big Bang hypothesis, complexification occurred gradually after the universe entered the expanding phase. However, according to the Quran, complexification occurred in a static phase before the universe transitioned into a dynamic, expanding phase. Here, the role of evolution is limited. Evolution is not the primary creative force but rather indicates certain changes in the cosmos, such as changes in the state of matter over time, including the solidification of smoky matter and the expansion of space.
This evolution is included in the 6 days creation events. Here is the general application of such verse. He is the originator of the heavens and the earth. When he decrees a matter, he only says to it, "Be," and it is. Quran 2:117. The command, "Be," illustrates the instantaneous transition of systems from static to dynamic states, showing that creation was brought into existence not through gradual processes but through direct divine intervention.